Hello everyone, this is Mrs. Tippi Kulkarni, lecturer, Department of Physics, Scalars PU College, Belgavi. In this video, I am going to discuss 4th chapter, Motion in a Plane. The weightage of this chapter is 11 marks. So, one question from 1 mark, one question from 2 marks, one question from 3 marks, and one question from 5 marks numerical problem will be asked. Motion in a plane. So let us understand first what is a plane or 2D motion. 2D means 2-dimension motion. So in this chapter we are going to learn projectile motion and few more concepts, basic concepts. Okay. So let us begin with some basic concepts. What is scalar and what is vector? Physical quantities are basically divided into two types. First one scalars, second one vectors. Okay. Scalars means what? These are the physical quantities which are having only magnitude. Okay. Magnitude means in general it is a number. Okay. Examples: length, mass, time, temperature, energy, speed, etc. And how we express the scalar quantity or a scalar physical quantity? A scalar can be described by magnitude and a unit. Suppose if we are writing the mass value, then how we express? 1 kg, 2 kg, 3 kg, etc. Okay. Kg means what? It is a unit. Okay. 1, 2, 3 numbers are what? They are nothing but magnitude. Okay. Magnitudes. Similarly, time, 1 hour, 2 hour, 3 hour. Okay. Hour indicates what? That is time. 1, 2, 3, they are nothing but what? Magnitude. Okay. Next one, vectors. These are the physical quantities which are having both magnitude and direction. So here we have to remember both magnitude and direction. Vectors are nothing but they are also physical quantities which are having what? Both magnitude as well as direction. So direction is very important. In this picture I just shown here, push and pull means from where the person is pushing and pulling. Okay, means the direction is given or it is shown. Okay, the direction is shown in this picture. So the vectors are nothing but what? They are having both magnitude and direction. Examples: velocity, force, acceleration, etc. A vector quantity obeys vector addition rules. This is very important point. Okay. Some physical quantities definitely they are having the magnitude and direction. Then also we say that they are scalars. For example, current. Okay. So in such cases we have to remember this point. Vector quantity obeys vector addition rules. The physical quantities, if they are obeying vector addition rules, then we say that such physical quantities are vectors. Not only magnitude, along with the magnitude we have to remember these 2 points also, direction and vector addition rules. Okay. Vector can be described by magnitude, unit and direction. So 3 points are important here. So for vector we have to remember basically 3 points. First one, vector having both magnitude and direction, and vector has to obey vector laws, addition laws. Okay. So these are very important. Okay. So I just prepared few questions based on your understanding of vectors and scalars concepts. Okay. These are very interesting and simple, so which will help you for your CET, NEET or JEE exams. Okay. So here all of you know that these are nothing but what? These are the weights. Okay. And this is weighing machine. Okay. You just assume what is the total mass. Okay, so these are what? These are some weights which are having some values. Okay, 1 kg and 2 kg. Suppose if we put 1 kg, 2 kg masses in this weighing machine, what is the answer? What is the total mass? 1 plus 2. Definitely it is 3 kg. 3 kg. Answer second one, 3 kg. So this is a good example for scalar quantity. Okay, when we talk about the scalar, then we can take the algebraic sum of the physical quantities. Only in the scalar quantities it is possible. Okay, so this is scalar. Mass is a scalar physical quantity. So we added by using simple addition method. Okay. Similarly, one more scalar example. Total in flow. You just carefully see in this picture. So here two taps are there. From one tap it is a 15 liter per meter, minute, 15 liter per minute, and this is 3 liter per minute. Okay. Then what is the answer? Definitely 18 liter per minute. So 15 plus 3 is equal to how much? 18. Okay. So here also it is a scalar quantity. That is the reason we added by simple addition method. Suppose if we consider vector quantity. Okay, vector physical quantity. For example, force. Force is a vector. Okay, in this case, how we have to add them? Okay, is it possible, or we have to apply only the simple addition method? Okay, let us understand. This is wooden block we have to consider. Okay, we have to consider this is a wooden block. Okay, suppose if we consider this is a wooden block, then one person is applying the force in this direction and force value is 5 Newton. Another person is applying the force in the opposite direction with respect to this, and that value is also 5 Newton. Okay, Newton is the SI unit for the force. Okay, carefully see the directions are opposite. Values, of course, force values are same, but directions are opposite. So we cannot add or subtract them easily. Why? Because force is a vector quantity. So vector rules will not allow to add or subtract by using algebraic addition and subtraction rules. Okay. So in this case, we have to consider, suppose if we consider this is positive, with respect to this, the direction is opposite here. So for that reason this is minus. So total or net force is equal to what? 5 Newton minus 5 Newton is equal to 0. So answer is 0. Okay. Immediately the question arises, suppose if the directions are same. This is another example. If directions are same, forces are also same, then what is the answer? Can we add them? Yes, it is possible. So directions are same. Okay, both directions are same, values are also same. So we can add them. The total force is 10 Newton. Suppose values are not equal, force values are not equal, directions are also opposite. In this case, how we have to search the net force? This is 3 Newton, this is 4 Newton, directions are opposite. How to solve this? Is it not interesting? So we have to split this 4 Newton in this way, 3 Newton and 1 Newton. Total it is 4 Newton. Okay. So same diagram I just redrawn here. So I splitted this 4 Newton in this way, 3 Newton and 1 Newton. So 3 Newton get cancels. What is the answer? 1 Newton. Okay. So answer is A, 1 Newton. Another example. So here again the rectangular box. Okay. You just see the forces all sides. Okay, the force is applied on all sides. The value of this force is 2 Newton and this is 2 Newton. Directions are here opposite. Okay, here also it is opposite, but the values are like this, 3 Newton and 4 Newton. Okay, so in this case both the directions are opposite. For that reason 2 Newton is nothing but what? 0. How we splitted this 4 Newton in this case? Similarly, we have to split the 4 Newton in this case also. 3 Newton and 3 Newton get cancels like this. Total remaining force is 1 Newton. So the net force is 1 Newton. So these are interesting points which we have to remember. In physics, scalars and vectors are very important. If we know or if we study thoroughly them, then it is easy for us to solve number of problems. Okay. So based on scalars and vectors theory, there are some different types. Okay. Basically, vectors are divided in again subtypes we can see. First one, unit vector. It is a vector having unit magnitude. Okay. So if the magnitude is 1, unit means 1. If the magnitude is 1, such vectors are called unit vectors. And how we represent them? By using this symbol n cap. This is n cap. We have to read as n cap. Either n notation or we can use I, j, small I, j, k. Okay. So small letters I, j, k are also considered as a unit vector notation. Okay. So this is the expression for the unit vector. How we have to write them? A is equal to magnitude. These blue color parallel lines are nothing but magnitude, the symbol of the magnitude. We have to read magnitude, and vector symbol is like this. If it is an arrow, then we have to say vector. Suppose if we are writing vector A, then we have to read vector A, means this is a vector quantity. So for that reason we have to draw vector symbol in this manner. Magnitude of vector A into n cap implies n cap is nothing but what? Unit vector. So n cap is equal to vector A divided by magnitude of vector A. So same expression is written in this way. Okay. So n cap is nothing but unit vector. So unit vector, of course the value is 1. Then also we are using that in the to solve some problems or in a derivation. Why? Because to understand the direction of the particular quantity, we require that unit vector. Okay, I hope you understood this. Next one, parallel vectors. Like vectors, unlike vectors and equal vectors. Okay, so they come under parallel vectors. These are the vectors having the angle between them is either 0 degree or 180 degree. Parallel vectors are nothing but what? If two vectors are like this or like this, okay, such vectors are called parallel vectors. Of course the angle is 0 degree and 180 degree. Okay. The next one, like vectors. These are the vectors of same type having the same direction. So you just see the directions are same. Okay. And this is how we have to read vector A, vector B. Okay. So A and B are two vectors, directions are same. Such vectors are called like vectors. Next one, equal vectors or equality of vectors. So these are the vectors of the same type having equal in magnitude and direction. If both vector A and B, if directions are same, okay, as well as magnitude, suppose if the magnitude value is also same, such vectors are called equal vectors. Okay. Then how we have to multiply the vector by a real number? Okay. So this is the expression for that. Vector into positive real number is equal to what? Is equal to vector. This is a expression. So instead of vector, I use the notation vector A, and positive real number is what? It is denoted by lambda. Okay, so lambda into A. Magnitude of parallel lines are there. That is the reason how we have to read lambda into vector A. Okay, where lambda is what? Lambda is greater than 0. It is nothing but what? It is a real number. And A is what? A is a vector. Okay. For example, if we substitute real number value instead of lambda, if we substitute the real value, real number, that is 2, then how we have to write? How we have to multiply? 2 into vector A. So this is 2 into vector A, that is 2A vector. So this is an example for the multiplication of vector by real number. Next one, addition of vectors by graphical method. So here, triangle law of vector addition. We have to follow some rules while adding the two vectors. We cannot take the algebraic sum of the vector because we know that vectors are having the direction. Suppose if we consider two vectors, vector A and vector B. Okay, then how we have to add these two vectors? By using what? Triangle law of vector addition. If two vectors are represented both in magnitude and direction by the two sides of a triangle taken in same order, this is same order, then the resultant can be completely represented by the third side of the triangle taken in the opposite order. So we have to draw one imaginary line, or we have to join these 2 points. Okay, so if we draw this third side or third opposite side with respect to these two, this is called a resultant vector, which is opposite to what? Opposite to the vector A and B. So this vector is called what? Resultant vector, and it is denoted by the notation R, capital R. So when we join all these 3 points, is it not a triangle? So for that reason we call it as triangle law of vector addition. Okay. So here explanation is given. Consider two vectors, vector A and B. Okay. They are represented by the two sides of the triangle and taken in the same order, that is in the figure 1. It is given in the figure 1. The resultant can be represented by the third side of the triangle taken in the opposite order as shown in the figure 2. Okay. Another method is parallelogram law of vector addition. Statement: if two vectors acting at a point are represented both in magnitude and direction by the two adjacent sides. So two adjacent sides, A and B are two vectors. So both are two adjacent sides of the parallelogram. Then their resultant can be completely represented by the diagonal drawn from the same point. Okay. So these dotted lines are nothing but they are the imaginary lines. When we join these lines, is it not a parallelogram? Okay. So this bisector is called a resultant vector here. This is called what? Resultant vector. So how we studied the resultant vector in the law of triangle? Similarly, in this case, suppose if we consider the two vectors at adjacent sides, then the resultant is always at the diagonal side or at a bisector. Okay, this is very, very important. When we join these points, so this is like a parallelogram. So for that reason we say that law of parallelogram. So R is equal to what? A plus B. Vector R is equal to vector A plus vector B. So this is the notation for vector. So here explanation is given. Consider two vectors A and B are represented by the two adjacent sides of the parallelogram as shown in the figure 1. Their resultant can be represented by the diagonal drawn from the same point as shown in the figure 2. So graphically the resultant R, vector R is equal to vector A plus vector B. Next one, how we can subtract the vectors. Again we have to apply the same type of rule. The subtraction of B, suppose if we are subtracting the vector B from vector A, okay, from vector A is defined as the addition of what? Minus B to A, vector A. This is equal to what? Vector R. So I will rewrite the same expression in this way. Vector R is equal to vector A. First I will write positive number, then minus B, vector B. So this is what? Subtraction of vectors. I hope you understood the concepts subtraction and addition of vectors. If you need any further questions and answers from the 4th chapter, please go through the link given below. Thank you.